This video is all about showing you how to run Ark Survival Ascended on AWS or Amazon Web Services. So you're playing Ark Survival Ascended with you and all your friends, and you decide you want to host your own dedicated server because the official servers suck. But let's be honest, hosting your own Ark server takes a lot of compute resources. Maybe your home computer or your home network, for that matter, just isn't reliable enough to host your own dedicated Ark server. So then the next best option available to you is to go to a server hosting platform like Nitrado and rent a server from them for a monthly fee. And that works fine for a little bit, but then you decide you want more control. You really want to be able to put whatever you want on this server other than Ark. You really want to be able to dig into the operating system and customize it to really meet your needs. And in those instances, it makes sense to use a hosting platform like Microsoft Azure or Amazon AWS or Google Cloud. Now, if you're new to AWS and you don't have any experience with it, don't worry, this video is geared towards both beginners and people with experience in AWS. I'll show you how to create an AWS account, and I'll be showing you how to install and use Terraform so that we can deploy our Ark server quickly with a Terraform module that I publish. And Terraform is an infrastructure as code tool where we describe how we want to deploy our server and all the resources instead of clicking through the UI and saying I want a server and I want it configured like this. We describe it as code and we deploy it that way. Now I can already hear the people in the comments saying, why would you run this on Amazon Web Services? It's too expensive.
I am never going to financially recover from this.
When compared to a game hosting platform like Nitrado or some other platform. And to that I would say you are correct. If you leave the server, the actual physical server that we're going to create running 24 hours a day, 7 days a week, it will be more than a hosting platform like Nitrado or some other platform. However, we can reduce these costs, and if you manage them properly, it can actually be cheaper than those hosting platforms. So if you stay tuned to the end of the video, I'm going to go over some cost-saving tips, how we can automatically start and stop our instance when we're maybe not using it, and how we can set up cost budget alerts so that if our budget is expected to go over budget, we can get an email and be alerted to that. So obviously the first thing we need is an AWS account. So if we go to Google and we just simply type in sign up for AWS, the first link it brings us to is sign up for a free AWS account. And then once we're there, we're going to hit create a free account. Now, AWS accounts are free by their nature. They have what's called a free tier in which you can use certain things for a specified period of time. And when that time expires, it is no longer free. But while you're in that free tier trial, you can use things that are outside of the free tier and you'll begin to incur a cost. And it should be noted that in order to run a powerful enough server, we won't be dealing with the free tier. So you will need a credit card of some sort in order to begin using AWS. Go ahead and fill in these boxes, follow along with all of the prompts. It should take you anywhere from 5 to 10 minutes. You will need a valid credit card and your address, phone number, and email address. And here's where they ask you for your billing information, and this is required. Note, they will not charge you for usage of AWS free tier limits, right? If you stick within those limits, you won't get charged, but for our purposes, we will be exceeding those limits, so we will be getting charged. So you will have to provide this here. Once you get to the point after you've confirmed your identity, it says sign up for AWS, you pick a support plan. We don't need developer or business support. We'll do basic support, and then we'll hit complete sign up. Once you're logged into your AWS account, you'll see this services tab up here on the left, and this is a list of all the services that we can use within AWS. We will be primarily focusing on EC2, S3, and IAM for the purposes of this video. If you feel like going through here and exploring, feel free, but let's move on to installing the other piece we need for the video, and that is Terraform. Now you can simply Google install Terraform and you'll probably get these two links. So this one, install Terraform, leads to the tutorials section of the HashiCorp docs. And this one brings you to the actual page where you can download the packages. So if you click on this first one, you get a small video on how to download and install Terraform. And then they have a little tutorial that you can follow. You pick your operating system. Are you on Windows, Linux, manual installation? And then that second link, install Terraform. And I'll put a link to both of these in the description. This has all of the packages so you can download and install them manually. And that's what we're going to do. So if you're on Linux, you probably know how to use your package manager. If you're on Ubuntu, just follow these instructions. If you're on Red Hat, CentOS, right, to install Terraform. Pretty simple. If you're on Windows, it gets a little more complicated. Now, I'll be doing this on Windows because I expect most people watching this video are new to Terraform and running that from Windows. So we'll start with that. So again, I'll put the link in the description, but we're going to go to the Windows binary download, and we're going to go to AMD 64, unless you are on a 386 architecture system, but 99% of you are on AMD 64 systems, and we'll hit download. So you should have this .zip file in your downloads folder or wherever you downloaded it to. Go ahead and open that up, and we need to extract this to our computer somewhere. So I put mine in the F drive. I have a folder labeled Terraform, and that is where I put all of my Terraform executables. But you can put it anywhere on your computer. Now, the second thing I have to do is I have to tell Windows where Terraform is, the path on the computer to the Terraform executable. So to do that, we'll simply search for environment variables, and we'll hit edit system environment variables. And that'll open this window here, and we'll simply go to environment variables, and then under user variables, we will go to path, open that up, and we will simply add the path to the Terraform executable. So you can hit new, and then wherever on your computer it exists, right? If it's on your C drive, Terraform folder, you would do that. And so now when you run the Terraform command, Terraform will look through all of these paths and say which one contains terraform.exe, and it will run it from there. So you can see I've already configured the path F drive /Terraform folder because that is the folder that terraform.exe is in on my computer. So then you can hit OK, OK, and OK. And now to test it, you can open command prompt or PowerShell, and you can simply type terraform -- version, and that should return a valid Terraform version. And so you've successfully installed Terraform on Windows. So now we have everything we need to get started writing our Terraform code and deploying our Ark server. But real quick, tell me that you're using Visual Studio Code. And Visual Studio Code is an integrated development environment. It's super easy to install. And if you're into software engineering or cloud or development or just writing scripts on your computer, it makes things so much easier. So I'll leave a link in the description. Go ahead and install Visual Studio Code. It is not needed for this video. You can do everything we're going to do from like a notepad if you're sadistic, and PowerShell or a command prompt terminal if you so choose. Or if you're on Linux, you can just use Vim. But what makes Visual Studio Code so great is we can not only have all these different windows open and we can have like a bunch of files open at once, but we can install extensions, right? So we're working with Terraform. So if we installed a Terraform extension, it'll help us with our syntax, it'll highlight errors for us, and it makes really writing any kind of code just a lot easier. So to get started, the first thing we need to do is somewhere on our computer, we need to create a folder or a directory. This is going to be our working directory, Terraform working directory. So this is the directory all of our Terraform files will go. And this is the directory that when we run Terraform commands, they will run from this directory and look at all those files. So on my desktop, I have created a folder called Ark Terraform Deployment. So if you're not using Visual Studio Code, you could open something like PowerShell or Command Prompt, and you can just copy that path to that folder that you created, and you can CD or change directory into there, and now you're in that working directory. So when you create your files, however you're going to create them, you can just run a Terraform plan and apply from here. So for those of you that are using Visual Studio Code, over here in the top left, we have the Explorer icon. We're going to hit Open Folder. And you're going to navigate to that folder that you created, and you're just going to open it. And so now this is our working directory, the Terraform working directory. And we're going to create our first file here, and we're going to call it main.tf. Now, Terraform files all end in the extension .tf, and it does not matter what you name it before .tf, but I am following the Terraform, HashiCorp Terraform best practices for file naming conventions, and main.tf is always your entry point for any Terraform code that you write. And then we're going to go over to this website, registry.terraform.io, and I'll leave a link in the description. And this is the Terraform registry where anyone can write a Terraform module and publish it. So I'm going to look for the Ark Survival Ascended module that I've published. And now, what is a Terraform module? Well, if you're familiar with Python or Go, right, these are like packages, Python packages or Go packages. Someone else has written the code, and all you need to do is download the package, or in our case, the Terraform module, and then you can provide whatever inputs whoever has written that module allows you to in order to use it. So it's a way for us to write code once, upload it somewhere, and then reuse it over and over and over, and not have to keep rewriting the same code over and over to accomplish the same thing. So when you come to this page, there is a link here for the source code. So this will bring you to the GitHub repository for this module. And this repository has a README with instructions on how to use this module in different scenarios, any troubleshooting tips. It's got some pictures, but the most important part, there's an examples directory. And so this is an example of using this module in different scenarios. So different scenarios. So if you are interested in, say, starting a server with existing save files, you could go to the restore from backup example, and you could look at the README, or you can look at the main.tf, and you can see that there are restore from backup settings here, like start from backup. Where are your backup files? Are they on your local system? And then back on the module page, that same README documentation is also here, although pictures don't render, so I do suggest you go to the GitHub repository. There is an inputs section here, and these are all the available inputs that you can pass to the module, right? And they all have a description and a default value. So if you choose not to provide the value of an input, then one will be chosen for you, and this is the one that will be chosen. So if you choose not to say admin logging true, then it will always be set to false. And then also on the README, if you kind of go all the way towards the bottom, there is an input section that kind of appeals to the eye a little more with all of these inputs and their types and their default values, and if they are required or not. So once you've found a module that you want to use with Terraform, and in our case, we're going to be using this one over here on the right under provision instructions, we're just going to go ahead and copy this module block. And we're going to take that to our main.tf file, and we're going to paste that in there. And then source, this is where is the location of the module that you would like to consume, and then the version of the module that you would like to use. Now, version is not required. You could delete that if you wanted to, and then every time Terraform ran, it would use the latest version of the module. But we're going to keep it. And you can also adjust this to say greater than equal to, which means it will use any module version greater than or equal to this one. You could use this version constraint, which means only the rightmost version is allowed to update. So if I push version 1.4.2, it would automatically use 1.4.2, even though it says 1 here. But if I push 1.5.0, it would not be allowed to update this 4 to a 5. So here in this module block is where we will provide all of our inputs. So now we can begin to provide our inputs for the module. And the inputs that we can provide are documented on the module page under the inputs section. And they are also documented in the README. All the way towards the bottom, there is an input section. Now, rather than going through all of these, what we're going to do is we're going to go to the examples drop down, and we're going to go to vanilla Ark default settings because that is the example I'm going to use for this video. And we're going to go ahead and we're going to copy all of these inputs. And then back in VS Code, we are going to paste our inputs into this module block. So let's go over a few of these, not all of them. We would be here all day. But let's start with GE Proton version. For those of you who are not aware, at the time of this recording, Ark Survival Ascended does not have a native Linux support way to install it. So we have to run something like Proton and run Ark with Proton. And we're going to be running our Ark server using an Ubuntu Linux-based operating system distribution. So you can pick the version of Glorious Egg Roll Proton that you would like to use, and you can see here that the latest release is 8-30. I'm going to leave it at 8-27 because that is what I last tested with, so I know it's stable. Next we have instance type, and this is the type of EC2 instance or server on Amazon Web Services that we would like to use, and specifically this one is a 4-core CPU, 16 gigabytes of RAM server, and that is what is at least recommended for Ark. There are a lot of different types of EC2 instances as noted on the side of the screen here. And so we're going to use T3 extra large. So I'm going to leave that alone. We're going to leave create SSH key true and SSH public key. This is the path to an SSH key on your local PC. So right now here together, we're going to create an SSH key pair, which will contain a public and a private key. And the public key will be uploaded to Amazon Web Services and our Ark server, and then we will use the private key to connect to that server. So what we're going to do up here in Visual Studio Code is we're going to go to Terminal and we're going to go to New Terminal. And by default, this is going to open a PowerShell terminal right here in Visual Studio Code. So you can do this without Visual Studio Code. You can just open PowerShell or command prompt and follow along. And we're going to do SSH-key gen command. And we're going to name this key. So we're going to call it Ark AWS. We're not going to give it a passphrase, so we're just going to hit enter twice. And then our key is created. As you can see here on the left, we have a .pub for public key and Ark AWS for private key. And this is the one, the .pub, that will be uploaded to our server. And this is the one we will use to connect to the server. So we're going to provide the path to this file relative to this directory that we have all of our Terraform code in. So because the key is in the same directory, all we have to do is provide the name ark-aws.pub, and that's it. Now, if we had, say, an additional directory called keys, and we put the key in there, then we would have to say /keys/ark AWS pub. Subnet availability zone. So I have this set to US-East-1A. What does this mean? So if I didn't go over it before, in AWS, we have in the top right-hand corner a region dropdown. And so by default, the module that I have written is set up to use the US-East-1 region. And I will tell you how to tell Terraform what region to deploy things in a minute when we go over provider configurations. But just know that we're going to create a subnet, a network, and if your region is US-East-1, then there are a few different availability zones, right, within that region that you can place a subnet. Zone 1A, Zone 1B, Zone 1C, and that is what I am defining here. So when you configure your region later, if you say we're in Europe, Frankfurt, and you wanted to use EU Central 1 as your region, you would have to come in here and you would have to change this to EU-Central-1A or B or C or whatever is available to you. So I'm going to leave that US East 1A because my region will be US-East-1. Ark session name. So this is actually the name of the session as it appears when you log into Ark and go to look through the list of servers. So it's the server name. So I'm going to leave that Ark AWS Ascended. So let's change a few of these values. So I want taming speed to be 6 times. I want my XP multiplier to be 8 times. I want it to be PvE, so I'll leave that true. And I'll change the difficulty offset to 1.0. And so these are the settings that are going to be used when I install and start my Ark server on AWS. Now I want to take a second to note, I tried to turn most of the game user settings.ini files into inputs, but I have not worked on the game.ini file inputs. So if there is a missing feature that you would like to see in this Terraform module, please head on over to the GitHub repository, go to issues, and go ahead and open a new issue and open a feature request. I would also like to take a minute to tell you that if you are using the use custom game user settings setting and it's set to true, then you can combine your custom game user settings INI file with these settings, and these settings will overwrite the settings in your file. For example, if you were to upload a game user settings INI file of your own and it contains a taming speed multiplier of 8.0, well, if you provide anything other than 1.0 here, like 7.0, that 7.0 will override the 8.0 in your game user settings file. But if you leave taming speed multiplier at 1.0, the default value that Ark uses, or you just simply remove it altogether, it will just use the default value 1.0. And when the server starts, logic is in place that this value will not overwrite the value you have in your custom game user settings INI file that you provide. So there's one more file we want to create, and this part is optional. You do not need this file for this to work, but it makes our life easier. So we're going to create a new file, and we're going to call it outputs.tf. And then on the module code, we're going to click on the source code link to bring us to the GitHub repository, link in the description as well. We're going to go to the examples directory, and we're going to find that vanilla Ark defaults example, and we're going to go to outputs.tf, and we're just going to copy all of these outputs. And then back in VS Code, we are going to paste those into our outputs.tf. And outputs in Terraform are a way for us to access data about things being created and then display them, right? So when we create our Ark server, we don't know the public IP address yet. It doesn't exist yet. But when Terraform finishes creating it, we can use an output to have Terraform output it to the screen for us. So then we have the IP address so we can SSH in or log in without having to go to the Amazon Web Services console and click on the server and find the address that way. So we have an AWS account, we have Terraform installed, and we have Terraform code written. The last thing we need to do is to link all of this together. So we need to tell Terraform how to authenticate to our AWS account so that Terraform can begin creating the server and everything else needed for the server inside of our account. And we're going to do that by configuring our Terraform provider. So this video is by no means here to teach you how to become a Terraform expert or an AWS expert. I am just giving you the basic tools needed to do what we need to do for this video. So Terraform has a concept of providers, and a provider is essentially how you tell Terraform to connect to whatever you're attempting to create something in. And we are attempting to create things in AWS, so we need the AWS provider. Now the module requires the AWS provider, so when we run Terraform, it will download it and use it, but we have to tell the provider how to connect to AWS, which means we have to basically give it a username and password of some sort. So in order to do this, log into your AWS account and go to IAM, the IAM service. Now, if you're logged in as the root account, and if you just created your account, you probably are logged in as the root account. You'll see these security recommendations that you should deactivate or delete access keys for the root user. Now, I'm not here to teach you how to be an AWS expert, but you should know that it is best practice to come over here to users and create another user and then log out of the root user, log in as that new user, and use their access keys. Because if you're going to use the root access keys, right, then if somebody gets access to those, if you accidentally upload those to GitHub, then someone gets access to your entire AWS account. Whereas if you were to create a user and give them only the permissions they need. If someone got those access keys, they would have a very limited ability to do damage to your account. So for the purposes of this video, because this is meant to be beginner friendly, I am not going to create a user and go through that whole process. You're going to log in as the root account, or if you're experienced, log in as a user with the correct permissions, and you're going to go to manage access keys. And you're going to see a section called access keys here. Now you shouldn't have any access keys, or you might have like one set of access keys, but you should be able to click on the create access keys button over here on the right. And if you don't see the option to create an access key, on the top right, very top right, it has your account name. Click on that, and one of these options that you can select are security credentials. Go ahead and select security credentials, and it will bring you to this page where you can see your access keys and create an access key as well. And you can only have a maximum of 2 access keys at any given time. And when you click create access key, it's going to ask you if you understand. And again, you're going to get the warning about the root user key. And it's going to give you that access key and a secret access key. So this is essentially your username, and this is your password. So go ahead and copy these, put them somewhere safe, and then you can go ahead and hit done. So now we have to give Terraform this access key and secret key so that it can connect. So the AWS provider, we can hard code these credentials into a provider block, although that's not recommended, because if we accidentally put this code somewhere, say GitHub, now someone has access to this key. And so you see where the danger lies in using those root access keys. The way we're going to do it for this video is we're going to set environment variables. So if you're on Linux, all you need to do is copy these commands and then change these values to use your AWS region, your access key, and your key ID. And real quick, if I didn't explain what a region was yet, in AWS on the top right, you'll see like North Virginia or some other region. This is what they mean by region. So depending on where you want to deploy your server, right? If you live in Europe, you're going to want to deploy a server in Europe, not US East 1. Now, if you're on Windows, this command, you're not going to be able to copy and paste it. We've got to set the environment variables, and that's different when it comes to Windows if you're using PowerShell or command prompt. So back in VS Code, I'm going to open a new terminal again. This is going to open up my PowerShell command prompt. So the equivalent command in PowerShell to those export commands would be, and I'm just going to open a new file right here and call it temp, this command here. So $env : and then our environment variable and the value. So go ahead and take that access key ID and that secret access key and the region you would like to deploy into, and go ahead and modify this real quick. So I've gone ahead and edited these environment variables, and now I'm just going to go ahead and paste them into my PowerShell window and hit enter. And now all 3 of these should be set. So now when I go to run Terraform, it's going to look at the environment variables and be like, hey, I found an Amazon Web Services username and password and region. I will deploy all of these into that account. Now with our Terraform code configured and our AWS credentials configured, we're ready to start running Terraform. So we're going to start with a Terraform init command. And this is going to initialize the Terraform working directory, this directory right here. And so Terraform looks at all our files and it says which providers and modules are we using, and then it goes and downloads all of those from the appropriate places. Real quick, people have reported getting an error, this one here on the screen, when they run a Terraform init. If you get this error, go ahead and install Git on your computer, Git, as well. It's super simple to install. Once Terraform is initialized, we can run what's called a Terraform plan using the Terraform plan command. And a Terraform plan will run through our Terraform configuration and look at everything we are trying to create, and it will output the plan. Here's everything we are attempting to build and what the properties and attributes will be if we know them already. And if we don't know, then they will be known after apply. So for instance, here is one of our Terraform resources, our AWS Elastic IP address. We don't know any of this information yet because it hasn't been created yet. But once Terraform creates it, we will get an output for the Ark server public IP. And then there are some other outputs here that I've put here. For the Terraform veterans watching this video, no, I did not make these sensitive, and I did that on purpose. And we can see that Terraform is attempting to add 11 things, change 0 and destroy 0. So then the next step is to finally run a Terraform apply, and this will actually start creating our resources. Now, when we run a Terraform apply, it reruns a Terraform plan, and then it asks us, is this okay? Is this what you want to do? And then we have to say yes. And so then Terraform goes off and it creates everything in our Terraform configuration. So our Ark server is being created. So the Terraform apply is complete. That took all of 30 seconds. And now we can see some of our outputs here, such as the public IP address of our Ark server. Additionally, if you were to go to your AWS console and clicked on the EC2 service, or in the top left, searched for the EC2 service, you should see one instance running under instances running. And if we click on it, we can see that our Ark server is initializing. And if you click on that server, you'll get access to information about it, such as that public IP address. It'll also have a security tab you can click on. And this is the security group that got created. And this is based on your inputs, such as your Steam query port or your Archon port. If you enable that, will be added here. So this is how we are locking down our server and saying we're only allowing traffic from anywhere in the world on these ports. So once you get this output here, go ahead and copy the IP address, and we are going to now SSH into our server so we can check out what's going on. So we're going to run the command SSH-I, and then we're going to provide the path to our Ark AWS private SSH key. So that would be this one here that says private key at the top. And so since it's in this directory, we can just do ark-aws, and then the user that we want to connect as, and it's going to be Ubuntu at, and then that IP address. And then we hit enter, we type yes, and then we connect to our server, and we're in. So I made this Terraform module very opinionated. You don't have a choice. Ark will be installed into /ark-asa. So you can type cd for change directory, and then move into that directory. And it's going to take anywhere from, in my testing, sometimes it takes 10 minutes, sometimes it takes 20. It just depends on how AWS is feeling that day for Ark to finish installing. So once it's done installing, this directory will populate. But in the meantime, you can run some commands. So you can run journal ctl journal cuddle -xu cloud-final. And this will let you view the install script as it's going on. So if you hold space, you can scroll all the way down, or if you hit Shift G, it'll bring you all the way to the bottom of the current progress. So we can see Ark is installing and it's at 34%, and it's 9 gigabytes. So that's what takes so long. Now, if you're an AWS experienced user, you could probably bake your own AMI and make this go a lot quicker. So then once this script finishes running, what you can do is you can run systemctl status ark-island, and that is the name of the service that is running Ark. So we'll see it's active and running, and we can see this, which means Ark is up and running. And then if we do an ls, look at all the files, we can go to shooter game, saved, config, Windows Server, and we can look for game user settings.ini, and we can look for something like the XP rate, which we modified, and we can see it's set to 8. So with our server up and running, it's time to actually connect to it. So when you're in the list of servers, you want to make sure that the show players servers box is checked, and you want to search for your server name. So I have Ark AWS Ascended, and there's my server. So I can try to connect. And I am in my server. So I'll exit the server with the exit command. And then if you determine you no longer need this server, you can simply run a Terraform destroy, and that will destroy all of the infrastructure. So you're not being charged any money when you forget about it, and there's nothing hanging out in your AWS account that you don't expect to be there. And all of our infrastructure is gone. So that's it for the video on how to run an Ark server on AWS using Terraform. Now, I did promise you cost-saving tips at the end of the video. We'll get to that in a second. But first, if you enjoyed this video, if you're enjoying this Terraform module and it actually provides value for you, head on over to the GitHub repository, star it. If you would like to contribute, I'm open to that as well. In fact, I welcome it. If you have an issue, maybe there's a feature you want to request or a bug you would like to report, or you just simply have a question, head on over to the GitHub repository, go to issues in the top left, and open an issue. So if you stuck around to the end of the video, I did promise you some money-saving tips when it came to using AWS. Now, the majority of your cost is going to come from the actual EC2 instance running itself. You know, you don't get charged when it's just sitting there off, but you do get charged when it's running. That's where the majority of our cost is coming from. So AWS actually has a calculator. I'll leave a link in the description, and we can estimate these costs real quick. So if we come to the estimator and we choose EC2 for our service, right, we know we need 4 cores and 16 gigs of memory. And so it doesn't really matter what we choose. Right now, I've shown you the example T3 extra large. If I do on demand, so I'm not using a cost savings plan, with 100% utilization, meaning I leave it running 24 hours a day, 7 days a week, it's going to cost me $121 a month. So roughly that $4 a day. And, you know, we can kind of play around with this. We can choose different servers, right? And the cost kind of goes up or down by a few dollars, but it doesn't change all that much. I think the cheapest would be the T4G extra large. And, you know, it goes down to $98 a month, but that's still pretty substantial. And then we can't use spot instances because we can't have our server just disappearing on us while we're using it. But what we can do is we can control the utilization of this server. So if I were to say move this down to 40% usage of the month, well, now that's a little more manageable, $40 a month. So if we break that down into hours a day, right? So maybe I only need to play 5 hours a day. I come home from work and I only leave the server on for 5 hours a day because that's how long me and my friends have to play, or maybe hours a week. So, you know, maybe on the weekends, me and my friends, we all just have a gaming binge and we play for 15 hours a day. So 30 hours a week, right? A lot more manageable. So one of the best ways we can save on costs here is just turning off the server when we're not using it. Now, I realize that doesn't work for everybody because sometimes you want your friends to be able to log in and you have different schedules. You know, when you're asleep, they want to play, vice versa. And in those instances, there's really nothing we can do about that. And that is when it would make more sense to probably go with a server hosting platform. But the main benefit of using your own AWS service is you get that maximum control. So the most efficient way to do this is if you know, or you have pretty consistent time frames, maybe you and your friends can only play 3 p.m. to Friday to 5 p.m. on Sunday, then you can set an auto schedule for these instances to stop after 5 p.m. on Sunday and start again on 3 p.m. on Friday. But if you'd rather just, you know, start it when you need it and stop it when you don't, I'm going to show you to do that manually real quick. You can go to the EC2 service and you can go to your Ark server or instance. You can click on it, and over here in the top right, you can hit stop instance. Now that will not destroy it. It will not destroy your server or your data. It will not hurt your Ark server. It will simply turn the computer off. And then when you're ready to start it again, you can instance state and start instance. Now, if you're interested in auto scheduling when these start and stop, you will go over to the CloudFormation service. And we will create what's called a stack. And we will keep template is ready and Amazon S3 URL as the default settings. And we will paste this URL link. And I'll put a link in the description to this URL as well. And we're going to hit next. And this stack is basically going to create a Lambda function that runs every now and then to look at all the instances and say which ones are tagged a specific way and do I need to turn them off or start them. So we'll give it a name. This will be EC2 auto start stop. Name it whatever you want. And for the parameters, the instance scheduler tag name. And this tag is how the auto start and stop function knows which servers to start and stop on which schedules. And we'll see that in a minute. But we'll just leave this as schedule. And then we'll leave all of this the same, but frequency, come down to frequency. This is how often the Lambda function is going to run to figure out if it needs to start or stop a server. Every time a Lambda function runs, it costs money, but it's fractions of a fraction of a cent. But it, we don't really need it to run every 5 minutes. So I'm just going to set that every 60 minutes. I'm going to leave everything else the same. By default, this will run in the US East 1 region. If you want it to run in a different region, provide your region here. And then I'm going to leave everything else the same and hit next. I'm not going to mess with any of this. I'm going to hit next again. I'm going to scroll down. I'm going to acknowledge, and I'm going to hit submit. So now you can see our stack is being created. And you'll see that CloudFormation is creating all of these resources that were in our stack. If we actually click on resources, we can see all the resources that are going to be created. And don't worry about pricing when it comes to this. A lot of this stuff is free, or it costs fractions of a fraction of a fraction of a penny, US dollars penny, when it runs. And I know it might look scary, but trust me when I say this is not where your costs are going to come from. It is going to be that instance running. So once your stack is created, you'll go up here in the top left to the Dynamo DB service, because the Dynamo DB table got created with this stack. If we go to tables, we can see our config table here. And then over here on the right, we're going to hit explore table item. So in here we have schedules and we have periods, and a schedule correlates to a period. So when we tag an instance with our schedule key, we tell it which schedule in here we would like to use to start and stop our instance. So if we look at the example one, Seattle office hours schedule, if we were to set that as our tag value, then our period would be office hours. And then if we look at office hours period, we start or begin at 0900 and we stop at 1700. So we already have a period configured here, weekends. And if we look all the way over to the right, we can see that Saturday and Sunday are set. So if we only want our instances running on the weekend, we can click on the running schedule. We can go to add a new attribute. We will add a string set. We will add periods and then weekends. And we'll save and close. So then we can go to EC2, servers, and ideally you would do this as code with Terraform. Click on your server and then go to tags, hit manage tags on the right, add a new tag, and this one's going to be schedule, and the key will be running. Schedule, running, click on it, tags, schedule, running. It is case sensitive, so make sure these are lowercase, hit save, and now this server should only run on the weekend. All right, one last thing to go over, and we're going to set up a budget alert. So you can come up here to the top left search bar and you can search for billing, and you want billing and cost management. And under the budget and planning section on the left, you want to look for budgets. And then on the right here, you have the option to create a budget. And so you can use a template or you can customize it. We're just going to use a template for ease of use. And you can set up these different budgets, right? So a zero spend budget is basically if I am going to spend anything over $0, send me an email. Or you can do a monthly cost budget. So let's do that. You want to give your budget a name. So monthly allowance. You want to enter the budgeted amount. So if you're estimated to go over this amount, this is when we will send you an email. So if you've only got $50 a month to spend, if we think you're about to spend over $50 a month, will send you an email. And then you want to put the email address of the people or person that you want to receive this email when this budget's about to go over, right? And then you'll just hit create budget, and there you go. And you can create multiple budgets as well.